Hello again, welcome back. Latest lesson on algebra that we've been looking at recently. We're going to look at simultaneous equations. Simultaneous just means at the same time. So usually we've looked at solving linear equations a lot. So a typical linear equation would be something like that. 3x plus 15 equals 21, and we know how to solve that using the balance method. I'm not going to go through every single step. There are older videos on the channel. If you do need to review that, please feel free to. But we know how to solve a linear equation. That's quite a simple one. We've got the answer x equals 2 there. What makes it linear is that there's the highest power of x is x. There's no x squared, there's no x cubed, there's nothing more complicated than x's and constants. And all the simultaneous equations we're going to look at are going to be linear as well. Okay, so if we're talking about simultaneous equations, it means we're going to have two things happening at the same time. You can have 3 or 4. We're just going to look at 2 simultaneous equations at the same time. So this equation that I've just solved, this linear equation, which is not simultaneous because there's only one of them, has got one unknown, x, thing we didn't know, although obviously I found out what it was, and one equation. If I'm going to solve some simultaneous equations, I'm going to have 2 equations and I'm going to have 2 unknowns. Usually, though not exclusively, 2 unknowns. Usually we're going to use x and y. There could be something else, a and b, whatever. So let's have an example. Very simple example to start with. If I've got 3x plus y equals, let's say that's 20. And if I've got 2x plus y, then that's going to be 14. So I've got 2 equations, 2 unknowns. I'm going to want to find out both values. I want to find out what is x and what is y. It's a good idea to get into the habit of numbering your equations. Now, you'll remember from all the stuff that we've done on the balance method that as long as I do the same thing to the left-hand side of an equation as I do to the right, then the 2 sides of the equation will stay the same. So what I'm going to do is I'm going to take the same amount away from both sides of the equation. I'm going to take this amount from the left-hand side and this amount from the right. And I'm allowed to do that because these 2 things are the same. So what I'm effectively doing is I'm doing equation 1 subtract equation 2. So if I do that subtraction, 3x plus y, take away 2x plus y, it's going to give me 3x minus 2x is 1, and I get no y. Shall I write that in? I'm going to write that in. I'm going to write it in dotted. So, plus no y. Don't usually write that in, but just for this step I will do. Maybe that wasn't the best idea. So 1x plus no y equals, well, 20 minus 14 is 6. So I now know that x equals 6. What's y? That's what I want to know. Well, that's also easy to figure out. Because all I have to do is take one of the equations, and I'm going to take equation 2. Doesn't matter which one, it should work for both. I'm going to use equation 2, which is 2x plus y equals 14. And I'm going to substitute in the value of x that I've just found. So I'm going to put in the value of x into that equation, and that gives me 12 plus y is equal to 14. So you can see if I take away 12 from both sides, oops, oh dear, all over the shop. Take away 12 from both sides, get y is equal to 2. Now, because I used equation 2 here, and I do want to do a check, I'm going to check in the other equation. So I'm going to check x is 6 and y is 2. Gives me the correct answer in equation 1. Let's just remind ourselves what equation 1 was. 3x plus y equals 20. So if I do 3x plus y, it should give me the answer 20. That's what I'm expected. Well, 3x is 3 6s, plus y is 2, so that's 18, plus 2, which is indeed 20. So it looks like this is my correct answer. X is 6 and y equals 2. And there are no other numbers that will give us the correct answer for both equations. There's only this one pair. X equals 6 and y equals 2. Now this process is called elimination. You'll see it's there in the objective. Because what we did is we eliminated the y's by subtracting. I did equation 1, take away equation 2, and that left me with no y's. They were gone. Just x's were left over. So we're going to look for opportunities to do things like that. I'm going to show you another example, one more example, that's maybe not quite as straightforward. So what if I had 5x plus 2y is equal to 31, and x plus y is equal to 5. Okay, this time, if I number my equations, I can't just do equation 1, take away equation 2. Because if I did, just move this over a little bit. Because if I did do that, I wouldn't eliminate the y's. If I did 2y take away y, I'd still have some y's left over. And that's no good, because for this process to work, I've got to eliminate one of the letters. Doesn't have to be y, could be x, but I've got to eliminate one of the letters. So that is not going to work this time, 1 minus 2. I've got to do something to one of the equations so that I get a situation like the one that we had before, where I had the same number of y's in both equations. So here's what I'm going to do, because you'll remember, as long as I do the same thing to both sides of the equation remains valid. So what I'm going to do over here is I'm going to take equation 2, and because I want these to be the same, I want 2y in the top equation and 2y in the bottom so that I can eliminate them. I'm going to multiply the second equation by 2 to get this new equation, which I'm going to call, rather alarmingly, equation 3. 2x plus 2y equals 10. Remember, you've got to do both sides. So I do that times 2 and that times 2 to get 2x plus 2y equals 10. And the other equation doesn't need to change. 5x plus 2y is equal to 31. And now, because they're both 2y because they're the same, I'm going to eliminate them by subtracting 1, subtract equation 3 this time. So equation 2 is back over here. And this is equation 3. 1 subtract 3, we get 3x. The y's cancel, there's no y's left over, equals 21. Which means 1x must be 7. So now I've worked out what x is, I can pick an equation and go back and work out what y is. And I can pick equation 1, I can pick equation 2, I can even pick equation 3. But it's probably sensible to go back to the very beginning and pick one of these two. Because that was the question, so if we've made a mistake anywhere, it'll show up straight away. So I'm going to go back to equation 2, because equation 2 is easier. There's less going on here. So I'm going to sub back into equation 2, x equals 7. So I've got 7 plus y equals 5. And obviously 7 plus y equals 5. If we take 7 off both sides, minus 7, we get y is equal to -2. So that should be our answer. X is 7 and y equals -2. Always do a check with these because it's so easy to make a mistake. I'm going to go back and check in equation 1. 5x plus 2y equals 31. So if I use x equals 7 and y equals -2, I do 5x plus 2y, I should hopefully get the answer 31. Well, 5x is 5 times 7 plus 2 times -2, which is 35, plus a negative number is the same as take away. 35 minus 4 is 31. And that was the answer I was expecting to get. So once again, looks like my answer, x equals 7, y equals -2, -2 is correct. So before I wrap up here, I just want, and this was a long one today, but it's a new concept to a lot of you, I imagine. Before I wrap up today, I just want you to think, how would it be different? What might I do differently if I've got these two equations? X plus y is 6 and 2x minus y equals 9. What would be the first step to eliminate y? And how is this? Think about how this equation is different. What's the first step? And as ever, if you have any questions, make sure you bring them with you as well tomorrow. Okay, wicked. I'll see you all tomorrow.